must know. All right, so opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. I'm not going to go into those in detail right now because each slide is going to go into those here. So, some vocabulary before we get started going into this. Parallel lines are straight lines that do not intersect. I didn't make these notes. As a geometry teacher, two straight lines in the same plane, if you want to be technical. Just to throw something fun at you, like you guys should be pretty familiar with parallel lines. Two lines run side by side, don't touch. But could you have two lines that don't look like this but still don't touch? Okay. How? Those would not be lines. Those aren't straight lines. So those are still parallel even if they're. So that's not what I'm talking about.
You can have them and they not touch like this.
Those two would eventually touch.
But no, like one stop.
Yeah, it's not a line anymore. Lines go on in both directions forever. They'll touch.
What happens if, wait, I have a...
Oh,
like this, like, you know, like it goes...
Well, they're still like, that's what we're thinking of parallel though.
Yeah, it is straight.
Okay, so like, let me give you an example. Imagine there's a line up there at the top of the ceiling. Like where the wall and the ceiling meet. Imagine there is a line right there. And it keeps on going forever out through there. Somebody give me a line that would not cross that line.
Like this.
Elijah.
A line that goes on the bottom of the floor, and that runs like this.
Correct. So if I have a line, so, all right, top edge of the room back there, right? Like it's parallel to the line on the bottom edge there. But, and they would not touch. But it is also not going to touch like the line going down on the floor, going down the middle of this room. Those two lines are not parallel, but they would never touch because they're in different planes, right? That one's on the ceiling, this one's on the floor. They're in different planes. So those are called skew lines. So that's why I'm adding this in here. You don't have to know that for what we're talking about. I just feel obligated as a former geometry teacher to tell you these things because we used to talk about that. Congruent means same length or same measure. Consecutive means next to each other. This one is important right here. You need to know this one for sure. Supplementary is adds up to 180 degrees. So two angles that are supplementary add up to 180 degrees. We're going to use that quite a bit. And we've already used the word bisect quite a bit. Bisect means cut in half, right? First property that we must know, opposite sides are parallel. So to have a parallelogram, the sides opposite each other must be parallel. So for example, AD and BC are opposite each other, and AB and CD are opposite each other. These markings right here, where we put the little arrows, show that two lines are parallel. So if you see a single arrow here and a single arrow here, that's telling you that AB is parallel to CD. They put a double arrow on the top and the bottom. Those lines are parallel to each other. They are not parallel to AB and CD, obviously, here. So we use two arrows there to show that it's not the same as this. Okay, so this is the markings you will see. Sometimes, in order for us to apply these properties, we have to know something is a parallelogram. If they put these parallel marks right here, that tells us it is a parallelogram, and we can apply any of the properties for parallelogram. So opposite sides are also going to be congruent. So if we have this picture here, we know that would be a parallelogram because they've marked the opposite sides parallel. So if I were to know, as it says here, that AD is 7, then what's BC? Is 7. Opposite sides are congruent. If AB is 8, which it doesn't look like. This is not drawn to scale. What is CD? Also 8, right? Opposite sides are congruent to each other. So some of the questions you're going to get are going to be as simple as having an 8 right here. You have to tell me the opposite side is 8. Okay? So some of them will be very simple. The ones that I'm going to give you. The ones that are going to put an exam are probably not going to be quite that simple. Here. But we got to work up to the hard ones. So opposite angles are also going to be congruent. I really do not like the way they have drawn this picture, because the way these are marked right now show they're all the same. Are they all the same? They are not. One of these should be marked with like a double arc, or sometimes another way you might see it, you'll either see like a double arc for one of them and a single arc for the other. Another way they sometimes show this is they might do like a single tick mark here and a double tick mark here. Either one of those are like mathematically correct ways to display that. Something should be marked there. So it's the opposite corners that have the same measure. So like if this, for example, if this is 36 degrees, which other angle would be 36 degrees? C. Okay. Some of the ones that you will have will be as simple as just telling me, you know, for example, if this is 110, which is not possible to be the case at the same time. I need to get back on these notes. I don't like that. That can't be 110 at the same time the other one's 36. That would be wrong. I'm going to fix it here. If that's 36, because of the next property that we're getting ready to learn, if that is 36, then this would have to be 144. So if that angle is 144, which other angle would be 144? B. There. So some of them will be as simple as that. Don't overcomplicate those whenever you see these types of problems. All right, now the reason I just changed my the numbers on that last problem is because of property number 4. Okay? Property number 4 says that consecutive angles are supplementary. So angles that are on the same side, that share the same side, should be supplementary, which means they add up to 180 degrees. So for example, consecutive angles could be A and B. See how they share that same side right there. Or it could be B and C right here. Or it could be C and D. Or it could be A and D. All right, so two angles that share the same side. So, for example, if angle A is 40 degrees, if you have a parallelogram, and let me mark this with a double angle here. I don't like the way they've got that marked. If I have one single angle of a parallelogram, I can find all of them, right? Because if I know A is 40, for our last property, I just found that C should also be 40. But I also know consecutive angles have to add up to 180. So whatever A is plus this other angle over here, B, they have to add up to 180, right? So if I do 180 minus 40, I will get 140. So this angle right here would have to be 140 degrees. And if angle B is 140 degrees, then angle D has to also be 140 degrees. And if you check here on any side, like if I look at AB, 40 plus 140 equals 180. If I check right here, between BC, 140 plus 40, that equals 180. Right here, 40 plus 140 equals 180. Same thing over here. I'm running out of colors, but 40 plus 140 would equal 180 for that. Okay. Questions? All right. The last one is your most complicated property, although it's still much easier than most of the triangle stuff that we were doing. So, bisect means to cut in half here. So, so the diagonals bisect each other. So it does not mean that they are equal to each other. It means that they cut each other in half. So whenever they cross right here, this piece has to be equal to this piece here. And then this piece would have to be equal to this piece here. Are diagonals equal to each other? Are they the same length? Okay, so AC is the same length as BD. Okay, if we get out our ruler here, if I measure it up here, BD is 15 centimeters. AC looks like a little over 11. Okay, diagonals are not equal to each other. In a rectangle, diagonals are equal to each other. But in parallelograms, the diagonals are not equal to each other. They cut each other in half. So they cut the diagonals in half. So they make equal parts right there. So, here is an example where we need to find the missing pieces. All right, so they give us, they should tell you this is a parallelogram. They don't, but they should tell you that this is a parallelogram because you should not make assumptions that it is a parallelogram. I'm going to tell you this is a parallelogram. So, Marley, give me one of these things that it's asking for here. Okay, AD would be 8. I agree. Okay. Jason, give me another piece that it's asking for. It's already marked, so they're not really asking for that. That one's also marked. Okay. But if AB is 15, what other side is 15? DC. So DC is 15. Okay, good. William, give me one of the angles that they're asking for. Good. B would also be 68. Okay. Easton, give me another angle that they're asking for. No, C is not going to be 68. 112 sounds better. How did you get 112? 180 minus 68 is going to give you 112, right? Because these angles that are on the same side have to add up to 180. So that would be, C would be 112. If C is 112, A is also 112. Were you doing, like, subtracting from 180? Okay, so 180 are the sum of the angles of a triangle. You could do it the way you were doing it, but a quadrilateral, anything with 4 sides, the angles add up to 360 degrees. So you would have to do 360 minus the 2 times 68, and then you'd have to take whatever you got and divide it in half, because you have 2 separate angles there. So you could do it that way, but it would need to be 360. However, the quickest way, if you know it's a parallelogram, is just to, like, these two have to add up to 180. So you can just take 1 and subtract it from 180. Okay, questions? All right. Here's example 2. Okay, they have asked us for several different pieces. Let's see. Katie up here, give me one. It doesn't matter which one. Which one? Yes, UT is 27. Okay? Passion says ST is 18. I agree. All right. VS 7. This is definitely not drawn to scale. VT is 15. RT would be 30. I said it was much easier than triangles. It's a better thing for us to be doing today. We'll probably have a little time to get into some review also. Yeah, you just have to know which pieces are congruent to each other. All right, and I think we've got one more. Is that right? All right. Okay, now this one is a little bit harder. A little bit like what we were doing on the warm-up, but still much easier. They're just asking you to solve for x. What do we know about these two sides that they have marked here? And it should tell you this is a parallelogram. They're congruent, right? So that means 9x minus 25 should equal 5x plus 7. So, Drew, how would I solve that equation right there? Okay, once we do that, what should we do? Okay, how do I move it? Good, we'll subtract our 5x. That will give me 4x minus 25 equals 7. All right, what comes next, Drew? Add 25. 4x equals 32. Divide 4. X equals 8. And this one only asks you for 8, so you're done for the x value. Now, it can ask you for like the length of PN, and then you would have to plug that number back in for that. Okay, questions? All right, so you have two things that you're going to do for me. The first is a delta math, okay? The delta math is going to have some that are very basic, where they're more like the first two examples that we did, and then it will have a few it asks you to do where it's a little more like example 3. The second thing that you're going to do for me, because we're a short class period tomorrow, and I want to make sure you guys get a lot of review, because I feel like we could use it on this. I've not felt super confident in your abilities on this unit. The first thing you're going to do is the delta math. I think most of you should get that done before you go, if you're doing your work. And then I have made a short review on Canvas that you are going to do. That one is homework tonight. It has 8 questions. It will tell you the answers. You can retake it if you do bad on it. So, for example, this first one, that is a parallelogram. What's the length of VS? 9. And then you move on. A few of them are going to be harder than that. Some of them should be fairly simple, though. So you are going to do delta math. You're also going to do this review on Canvas. It only has 8 questions. We'll do more review tomorrow, but I want us to go ahead and start thinking about a little bit of that review. Okay? Questions? All right. Everybody needs their Chromebook. I'm turning class-wise on. You guys got about 30 minutes, so please get out your Chromebook. If you got your own computer, put it away. I want Chromebooks. I am sorry, but the majority have proven themselves not trustworthy. A lot of the people who are... Yes, please. You'll need your phone. Delta math.